Hi Chem Peeps, this is another video on colligative properties. We're going to talk about a problem here where we have to calculate the depression of the freezing point and the elevation of the boiling point. So let's look at the problem that we're dealing with. It says chloroform has a boiling point of 61.2 degrees Celsius, so this is the original boiling point, and a freezing point of negative 63.5 degrees Celsius. So those are the original constant or properties for chloroform. Now, they also give us some other information. The K of B, so we do need this for the formula, is 3.63 Celsius per mole, and the K of F is 4.68 degrees Celsius per mole. What are the boiling points and the freezing points after 42 grams of the I can't pronounce that. You can see it's an organic compound. It is added to 0.6 kilograms of the chloroform. Okay, so we're going to be using these formulas. The delta T of F is going to equal the Van Hoff factor times the K of F, which is a constant, times the molality. And I'm going to come over here. The change in boiling point is going to be the Van Hoff factor times K of B, which is a constant, times the mole. All right, so let's talk about the Van Hoff factor. This compound, which is the solute, is being dissolved in the chloroform. It is carbon, hydrogen, and oxygen, all nonmetals. So this is ionic. So the Van Hoff factor is going to be 1. It is not going to dissolve. It's not going to dissociate. The molality, we're going to calculate molality, is going to be the moles of that substance all over the kilograms of solution. Well, we need to take this 42 grams of the solute and convert it to moles. So let's take 42.0 grams of the solute, ECU. I'm going to abbreviate it. I'm going to find the molar mass on the periodic table. It actually, for every 1 mole, if I add up all my carbons, hydrogens, and oxygens in that formula, 1 mole of it is going to be 154 grams. So that will give us 0.2727 moles. Now the molality is going to equal that 0.2727 moles divided by the kilograms of solvent, which is going to be 0.600 kilograms of the chloroform. So our molality is going to come out to be 0.4545 mole. Okay, so that's going to be an important thing for us to use. So let's go ahead and do the change in temperature. So if we do the change in temperature, delta T of F is going to equal the Van Hoff factor, which is 1, times the K of F value, which is 4.68 degrees Celsius per mole. They give us that, times the concentration, which is 0.4545 mole. I'm going to squeeze that in there. Okay, so if I calculate this, the temperature for freezing is going to change by 2. Great. The temperature is going to change by 2.127 degrees Celsius. Well, for colligative properties, when you add a solute to the solvent, it's going to depress it. Our original freezing point is negative 63.5. So the new freezing point is going to be negative 63.5, which is its regular freezing point, minus 2.127 degrees Celsius. And so the new freezing point is going to be negative 65.6 degrees Celsius. So there's one of our answers. Okay, so let's go to the change in boiling point. So if we're solving for the change in the boiling point, the Van Hoff factor is 1. The K of B is 3.63 degrees Celsius per mole. times the molality, which is 0.4545 molal. And so if we calculate that, our change in the boiling point is 1.65 degrees Celsius. So the new boiling point is going to be the old boiling point, 61.2 degrees Celsius, plus we're elevating it now that we've added solute to it. And so the new boiling point is going to be 62.85 degrees Celsius. Okay, so there's our second answer. I hope this helps application of elevation of boiling point and depression of freezing point. Find me in some more examples on YouTube and TikTok at Kim's Chem Chats. Please leave me a like or a comment and share this with others. See you on the next video.